Hello everybody, I'm going to go ahead and just go through number 4 on our notes. That's 2.7 day 1. You'll definitely need to make sure you know how to do this question, as it will most likely be on your quiz on Friday. So it says, suppose a spherical snowball is melting and the radius is decreasing at a rate of 1 inch for every 12 minutes. So right here, decreasing at a rate of 1 inch for every 12 minutes, that tells us how fast our radius is changing. So how fast our radius is changing is dr over dt. And since it's decreasing, it's negative 1 over 12. So that's 1 inch for every 12 seconds. 1 inch for every 12 seconds. Okay? It says how fast was the volume changing. So I want to know how fast the volume was changing. So I'm looking for dV over dt, how fast the volume was changing when the radius, so I know r, is 10 inches. Okay. So the equation that I'm going to be working with, let's actually get a picture going. Here's my perfectly spherical snowball. Okay. Here's my radius. If I want to know the volume of a sphere, I'm going to be working with my volume of a sphere formula. It's 4/3 pi r cubed. You will have to know that formula for this Friday. Okay. Once you get your equation that you're going to be working with, you just take the derivative with respect to t, so with respect to time. The first thing I'm going to do is take the derivative of v with respect to t. That's easy. That's just going to be dv over dt. Then I'm going to take the derivative of r cubed with respect to t. Now, remember, 4/3 and pi are constants, so I can actually just pull out my constants and then take the derivative of r cubed, which is 3r squared, but don't forget, since I'm actually powering down with r, so I'm taking the derivative with respect to t, that's implicitly, I have to multiply by dr dt. Remember, that's implicit differentiation. Alright, so the next thing I'm going to do is just simplify. I can cancel the 3's because I'm dividing by 3 and then multiplying by 3. So I have dv over dt is going to equal 4 pi r squared times dr over dt. Alright, the last thing you do is just fill in your given information. I don't know dv over t. That's right there. I'm trying to find dv over dt, so I'm going to leave it like that. Remember, dv over dt is the rate, how fast is my volume changing. Okay, 4 pi, and I want to know when my radius is 10 inches. So I'm going to substitute 10 in there, square that, and I know my dr dt, that's how fast my radius is changing. My radius is changing is negative 1 over 12. Okay. You can go ahead and leave pi as your final answer. So dv over dt, put that whole thing in your calculator. Hold on, I actually have to put it in my calculator. So I have 4 times 10 squared, which is 100, times negative 1 over 12. Make it into a fraction. It would be negative 100 over 3 pi. Or, if you decide to multiply by pi, it would be negative 104.72 when you round to the hundredths. Okay? So that would be my dv dt. dv over dt. So that's how fast my that's how fast my volume of my snowball is changing. It's going to be negative because remember, my volume of my snowball is decreasing because it's melting. Alright, and then the last thing you do is just write a summary sentence. I will mark off points if you do not include your units in your final answer. So, we just say the snowball's volume is decreasing at a rate of, you can say negative 100 over 3 pi, or, you don't have to say both, negative 104.72. Now remember our units. I think it's inches, right? Let me check. Yep. Inches cubed per second. Remember, we're talking about volume, and volume has cubic units. When the radius is 10 inches. Always got to have that last sentence because the volume is changing constantly. I just found what the volume is changing specifically when the radius is 10 inches. Okay, and that's how you do basically all spherical problems when you try to find the volume. Hint, remember, you're going to remember, make sure you know how to do this question for the quiz. Alright, I hope everybody has a great break, and I will hopefully see you when I come back. Bye!